when you're learning just the basics of evolution, you learn that altruism is an effective way to ensure that your genes will continue, because acting in an altruistic manner benefits a total percentage of your own genes greater than what you possess within you. So if a group of meerkats were out in the middle of the field, one stands up and sees a predator, and the group around her is all of her sisters, she's going to give the alert call so that her sisters can get to safety, even though that's going to draw attention to her from the predator. However, if she were in a group that were not a bunch family, if she were not in a group of her kin, it would do her better to not give that alert cry, because that way she has the time to run and everyone else is at danger. The way this works is that when you have a group of your kin, your direct kin, each one of those has, say, in a sister or brother, 50% of the same genes that are within you. Statistically speaking, we're going to go for the simplest genetic exchange, where everybody gets, half the mom's genes, half the dad's genes. So you have a 50-50 chance of getting the same combination of gametes and whatnot. So each of those sisters is a 50% survival rate for your genes. And so if there were 2 of your sisters and you gave out the alert code, you would have a net a 0 loss gain. Whereas each additional sister means that you have that much more chance of your genes perpetuating. Now let's bring this back to humans. Since we, as a species, for millions of years, we're not in large group settings. Our social genetic code was engineered to benefit our genes within the group. We ended up evolving altruism because altruistic acts within a group benefited your genes, no matter what you were doing or who it benefited. You were benefiting yourself, basically. Now take that out of the roving band concept, bring that back into the large cities and things today. Most people that you come into contact day in and day out do not share your genes. Essentially, what you do when you act altruistically towards a person who is not your relative, or in another case, you act altruistically towards someone who might not reciprocate, you are expending your own energy to benefit somebody else, and you get absolutely nothing from it.
The reason people give preferential treatment to genetically similar others is both simple and profound. They thereby replicate their genes more effectively. Altruism is a very interesting phenomenon, even recognized by Darwin as an anomaly for his theory. How could it evolve through his hypothesized survival of the fittest individual when such behavior would appear to diminish personal fitness? If the most altruistic member of a group sacrificed themselves for others, they ran the risk of leaving fewer offspring to carry forward their genes for altruistic behavior. Hence, altruism would be selected out, and indeed, selfishness would be selected in. Altruistic behaviors, however, occur in many animal species, some to the point of self-sacrifice. For example, honeybees die when they sting in the process of protecting their nests. As already pointed out, Darwin proposed the competition of tribe with tribe to explain altruism. Indeed, he actually titled his epoch-making 1859 publication On the Origin of Species by Means of Natural Selection or the Preservation of Favored Races and the Struggle for Life.
Why? This is Charles Darwin. Why on earth should there be a tendency for like to go with like? And Charles Darwin had his theory of evolution, and one of the biggest anomalies in his theory was altruism. Compassion, as Jared was talking about earlier, goes far down, well, not compassion, but altruistic behavior goes far down the evolutionary scale. Ants are one of the most altruistic species that there is. If an anthill falls in, the soldier ants come out and they defend it. The worker ants come out after them, they repair it, and they repair it so that they are in fact left outside along with the soldier ants, who are then overwhelmed eventually by the enemy soldier ants. So these individual ants have sacrificed their individual lives for the good of the hive. And Charles Darwin was saying, well, you know, my theory really is about survival of the fittest individual. So you might think that the most selfish individual with the sharpest elbows, who elbowed everybody else out of the way, was the person whose genes were going to get replicated. How does altruism, caring for others, get selected? And so there were various theories of the good of the species and so on that were mounted, never very satisfactorily answered. And Charles Darwin recognized this as what we call in science an anomaly, or a little paradox, a problem for the theory. You accept the theory because it explains so much, but this little paradox remains niggling away for maybe decades. So altruism isn't just there in ants, it's there in many, many species. Ground squirrels and chimpanzees willingly sacrifice birds themselves for other birds. How does this get selected by evolution? Next slide. Well, the answer is sociobiology. This is William Hamilton in 1964 put out a genetical mathematical model to explain it. And he did it in such a precise way that everybody finally said, yes, William Hamilton solved Darwin's paradox. And he launched the new discipline of sociobiology. His argument was very simple, obvious really when you think about it, that if the altruist sacrifices his own life for copies of his own genes in others, such as his offspring or his siblings' offspring, then those same altruistic genes will get replicated. So this is a selfish gene perspective. Altruism is selfish. It's in the service of replicating genes. And that's all there is in life as far as an evolutionary biologist is concerned, is genes replicating themselves over and over. Human beings, all animals, all cultures are just vehicles for the replication of genes into the next generation. Next. And that launched sociobiology. In 1975, evolutionary thinking suddenly came back not only into biology, but into all the behavioral sciences. And this is the cover of E.O. Wilson's book, famous professor at Harvard University.
Yeah, I think it's embedded in the trait of humanity that we haven't paid enough attention to, tribalism. We're often nowadays saying, well, you know, religious extremism is the cause of all our troubles. It isn't. It's the instrument, and the proximate justification extremists use, you know, is that they are obeying God when they kill, murder, take over. But what really is shall I say, at the Achilles heel of humanity is tribalism. We have a powerful tendency, undeniable, to form groups and to seek identity in a group, to submerge ourselves in the purposes of the group, to have something in our minds and in our goals larger than ourselves to obey and support. Tribalism. But it's very powerful, and it does lead, under wrong leadership, under the delusions that it creates, to the fear and hatred of other groups. And if this is perpetuated at the level of nations or groups that are able to organize and act aggressively, then you can have the kind of horrors that you allude to. And so it leads us to the question, why is this so? Well, actually, Darwin in The Descent of Man probably had close to the right answer. And he said that it is likely that human evolution was driven in substantial part by group selection, that is, group versus group, intergroup competition. One group, tribe, whatever, clan, whatever it was, acting aggressively toward others and defending territory, acquiring territory, dominating if they can, enslaving if that's possible. And that notion, and there's perfectly good models, incidentally, genetic models, that show how this then could drive the mental capacity, could drive aggressive instincts.
The next one. This is a 1976 book by Richard Dawkins, equally famous professor at Oxford University, and he brilliantly titled his book The Selfish Gene, because that captured the essence of this general argument. Now, the selfish gene by right-wing groups and left-wing Marxists and so on who wanted to argue that this was all, everything was due to culture, were suddenly on the defensive. And so they were denouncing this as racist and fascist theories. And if you go to the next slide, this is a paper, this is an editorial that Richard Dawkins wrote in Nature in 1981. And it's called Selfish Genes in Race and Politics. And the editorial was denouncing the National Front in Britain because they had picked up this idea of selfish genes, and in an article called, a journal called New Nation, and basically said, yes, nationalism is natural. It comes right out of our genes. Sociobiology says this, so the British National Front is correct in what it's arguing. And this was scary enough that Richard Dawkins denounced this in Nature, which is the leading biology journal. And he said, no, the National Front have got it wrong. They've misunderstood selfish gene theory. They've misunderstood Richard Dawkins. They've misunderstood William Hamilton. And his reasoning went like this. If you give 50% of your genes to your child, 25% to your grandchild, 12.5% to the next generation, 6.5% after that, 3% after that, 1.5% after that, well, it's vanishingly, your genes vanish very quickly, 6 or 7 generations and they're gone. There is no way to keep your immortality of genes going forward. And that's the mathematics of William Hamilton's theory. And he even used the analogy of Queen Elizabeth II of Britain not sharing any genes of her great-great-great-great ancestor, William the Conqueror, who conquered England in 1066. Even though she's a direct descendant, he said, there's no genes in common. Well, it convinced a lot of people, and on the pure mathematics of William Hamilton's theory, he was correct. But I and other people basically argued that this is much too narrow a perspective. If we go to the next slide, I'm not sure it's that. Oh, yeah. So in 1984, about 3 or 4 years later, I published a paper called Genetic Similarity Theory, which essentially argued that if a gene can recognize a copy of itself in others in a kin, then it can recognize a copy of itself in non-kin. All you have to do is recognize a copy of the same gene. And so altruism could be much more broadly defined than just within the kin group. And so I called it genetic similarity theory in order to differentiate it from kin selection theory. By 1989, which is the cover of the paper that I'm showing you there, we had actually carried out several studies to show that at least people were, in effect, recognizing copies of their genes. Go to the next slide.